Assalamualaikum and good morning. My name is Mahakim bin Ahmad, and with my teammates Nur Adlina Hazwani binti Abdul Rahman and Fairuza Fasha Rahadisti from Group EH200-4J, we will be presenting for our tutorial 3 resource allocation for the subject CPE 520. So, what is resource allocation? So, in any project management, resources are the most integral part for the success of the project. Without proper planning, these resources can be wasted and which can lead to a loss of production and efficiency of the project. So there are two kinds of schedule problems which can be split into time constraints and resource constraints. The best method to settle resource constraints is the parallel method, which is the process that schedules activities based on the constraints involved. So for our resource allocation problem, during the construction of a small chemical plant, construction equipment such as tractors are used. However, due to a budgeting problem, there are only 3 tractors yet that can be used at any given time. So activities A and D only need 1 tractor, while activities B, C, E, and F require 2. So initially, an AON diagram and resource loading chart are constructed before constructing a new one based on the constraints. And this is using the parallel method, which settles the resource constraints based on the parallel method. Okay, so next. So this is the resource schedule of work, starting with A and B, which will produce activity C, D, and E, which will lead to activity F, which will conclude the project. So for this schedule of work, the critical path is B, D, and F. Next is the resource constraint schedule. As you can see, resource A only takes duration of 4 days. Activity B takes 5 days. Activity C requires 4 days or so. Activity D requires 5 days, E requires 3 days, and F requires 2 days. But as you can see, based on this resource constraint schedule, during some days, there is an excess of use of resources, which means there is not enough resources to complete the activities, as you can see during number 5, 6, 7, and 8. So in order to solve this problem, I'll give this to my teammates and they'll show you how our solution to the problem is.
Next, let's move to the next slide, which is solution 1. Here, after we perform the CPM calculation, then we will draw the ES resource load chart as shown in the slide. If we look at the table, in the first row of the table, there are initials. First is ID, stands for the ID or activity, and then rest stands for the resource needed in each activity. Dur stands for duration. ES for early start, LF for last finish, and SL for select. And then we fill the table based on the CPM calculation that we already discussed before. For the example, for activity A, we need 1 resource here. Resource here is the tractor, 1 tractor, and the duration needs for the activity A is for A, and then ES, early start, late finish, and SL, you fill it based on the CPM calculation before. We do the same for the activity B until F. And then we fill the table in the right hand For the example, for activity A, for day 1 until 4, the resource needed for each day is 1, so we fill the cell with number 1, and we do the same for the rest of the activity. And if we look closer to the table, there are some cells that have a darker green color, but there is no number inside. It means that these are the selects for each activity. For example, for the activity C, in day 9 and 10, the color of the cell is darker green, but there is no number in it, so it means that this is the select of the activity C. After we fill the table for all of the activity, then we sum the resource scheduled for each day. Here in the table we can see that for day 5 until day 8, the resource scheduled exceeds the resource available. So we should shift some of the resource in each days to another day, so the resource schedule don't exceed the resource available. Move to the next slide. Here is resource constraint schedule through period 4 until 5, or in the 5th day of the project. So as we know that the resource schedule is exceed the resource available for day 5, so between activity B and C, we should choose one resource that will be shifted, considering the critical path of the project, the original critical path of the project, which included activity B, so we shouldn't shift the resources in activity B. So we should choose or shift the resource in activity C. Originally there are 2 resources in the day 5, so we move it to day 9. After we move the resources, we also have to change the number in Slack and ES. After that, we do the sum again, the sum of resource schedule in each days, and here we still can see the exit resource schedule within the resource available for day 6 until day 8. So we will continue to do the resource constraint schedule again in the next slide. So after that, we move to the next slide, is resource constraint schedule through period 5 until 8, or through day 6 until 8. As we know in the previous slide that the day 6 until day 8, the resource schedule exceeds the resource available, so we should choose between activity C or D or E that the resources will be shifted. Between activity C and E, for the solution 1, we choose the activity E to be shifted. Why activity D is not considered here? Because activity D is included in the original critical path of the project, so we shouldn't shift the resources in the activity D. And originally activity E start in day 6 until day 8, and it has like one slack day in the day 9, but we move it in the new ES is in day 10, because in day 9 the resort schedule is already reached the maximum resort available, so we start the activity E in day 10 until 12. As we know that the slack in the activity C is 1, and also we have slack in activity E in day 9, and the slack in the activity E is -2, so we have to take 2 from the other activity. We take the one slack in the activity C and one slack in the activity E and move it to the day 11 and 12 in the activity E. So the activity E will start in day 10 until 12, and then the slack of the activity E after we make up the new schedule is 0. As far as the slack in the activity C becomes 0 too. And after that we sum again the result scheduled for each day, and we can see that for the day 11 and 12 the result schedules exceed the result available. Then we have to make a result constant schedule again through the period in the next slide that will continue by my friends.
Okay, as mentioned earlier by Fariza, we have at day 11 and 12 we have exceed the resource available, and also at F we need to start after C, D, and E finish. Okay, so what we do here is we look at the late finish at IDE, which is 12. So it indicates that we need to start F at day 13. So the earliest start for IDF is at day 13, and the late finish for IDF is 14. Okay, and we can see that at day 1 until day 14, the resources schedule does not exceed the resource available. Okay, and from that, we build a new resource schedule work, which is start at A and B. First we fill up the earliest start and late finish, which is for A 0 and 5, B also 0 and 5, IDC, which is 5 and 9, IDD 5 and 10, and IDE 9 and 12, and lastly IDF 12 and 14. Okay, so we carefully add 0 plus 4, which is the duration at A, so it became 4, and at B we add 5, and so on until IDF, which is at early start 12, and we add the duration of 2, and it became 14. Okay, so we do the backward calculation. We start at 14, we minus 2, and we have 12. Okay, so at E we have 12, so minus by 2 we have 9, until we repeat the same process until at A and B, which is 5, 1 and 5, 0. Then we calculate the slack, which is if we compare back to the Gantt chart, it is the same. Moving on to the next slide, which I will show you another solutions in solving this problem. Okay, the first step is the same as Fairuza explained earlier, which is we fill up the ID, the resource person, the durations, the early start, the late finish, and the select, and we fill up the resource for each day until day 12, and then as you can see we have exceed the resource available. So what we do here is, let's see, we push the day, which is it will start which it can start early start at 8 and finish at day 12. And the same problem, F need to start after C, D, and E, so we push the F at day 13 and 14. So we add 2 at the early start and also add 2 at the late finish. It's okay. And if we look back at the IDC, the slack are -2. So to make up the negative value, we took 2 slack from IDE and give it and replace it at day 11 and 12. So the slack at IDE became 0, and the late finish we minus by 2, which is will be 8. Okay, after that we total up the resource schedule, and we can see that none of them exceed the resource available. Okay, here is the new resource schedule work for the solution 2. It is the same procedure. First we put the early start and the late finish from IDA until IDF, and then we do the backward solution at day 14 for all of the ID, and then we compare back to the resource constraint schedule. We will have the same value for the slack. I think that's all from us. Thank you.